another very important terminology in set. Proper subset. Proper subset. A set A is said to be a proper subset of set B, denoted by this symbol, if each element of set A is an element of set B. And there is a clause there. There is at least one element of B that is not an element of A. There is at least one element of B that is not an element of A. Let us look at this example. We have P is equal to set of A, P, C, that's the element. Then Q. The elements are A, B, C, D, E. Now let us go back to the definition. What are the elements of Q that are not in A? If you look at it properly, you see that D is not an element of P. E is not an element of P. Therefore, we conclude that P is a proper subset of set Q. It means P is properly contained in Q. P is properly contained in Q, as was discussed above, where P can be equal to Q. But in this case, P can never be equal to Q. So we say P is properly contained in Q. Now, good question. You have asked a very beautiful question, which I think I will illustrate with this material, the duster. You said, can Q be a subset of set P? Can Q be a subset of set P? Now let's look at this. This is Q and this is P. Can P be put inside? Can this Q be put inside P? It is not possible. So this Q cannot be a subset of set P. But if this is P and this is my Q, it is only inside. Let's look at it again. It is only inside. It means this Q is properly containing P, or P is properly inside Q. So we now see that P is a subset of set Q, which we write it as P is a subset of set Q. Look at it again. The dashed line is not below the symbol. It means P is properly contained in Q. In fact, Q is a bigger set. The converse is not true. Q can never be a subset of set P, because Q can never be inside P. And if you look at the example again, there are elements, two elements, D, E, that are here, but are not in set P. Types of set. We are going to take them one after the other and explain. The first one is finite set. So when do we say a set is finite? A set is said to be finite if it can be completely listed. A set is said to be finite if it can be completely listed or counted. If it can be completely listed or counted. Example. A is equals to set of vowels. A is equals to set of vowels. As a student of English, you know the alphabet. You know how many consonants we have in the alphabet. And you also know how many vowels we have in the alphabet. But let's look at the board. These are the vowels. A, E, I, O, U. Is there any other vowel? The answer is no. So how many elements do we have there? We have 1, 2, 3, 4, 5. So this is a finite set because it can be completely listed. It can be completely listed. Let's take another example. K is the set of X such that 2 is less or equals to S, less or equals to 5. Before we can determine whether it is finite or infinite, let us list the element. The element can be completely listed. So it's a finite set. It's a finite set. In fact, how many elements we have here? We have 1, 2, 3, 4. 4 elements. So it's a finite set. A set is said to be infinite if its element cannot be completely listed or counted. A set is said to be infinite if its element cannot be completely listed or counted. Let's take this example. P is the set of even numbers. What are even numbers? You would have done one in your... this is what you did in your elementary mathematics. Even numbers. These are just numbers that are divisible by 2. So 2, 4, 6, 8, 10, 12, 14, 16. So we cannot completely list them. It continues, it goes on and on and on. So it's an example of an infinite set. It's an example of infinite set. Let's take another example very quickly. X is the set of fractions between 0 and 1. Don't let it confuse you. It's an infinite set because the fraction between 0 and 1 can be so many you cannot completely list them. Let's list some of them. You can have 1 all over 3. You can have 1 all over 2. 1 all over 5. 1 all over 8. It will never reach 1. It goes on and on and on. In fact, here too, all this dotted line means infinite. That it has no end. You can also have it like this. Here. This one, it has no band at the beginning. It has no band at the end. So it goes on and on and on. So it's an example of an infinite set. This is a set which contains only one element. Can you think of any? In Nigeria, how many presidents do we have? We have just one president. It means our president is a unit set. In fact, unit means one. Unit means one. In every state of Nigeria, maybe Africa, there's only one governor in a state. So the governor is an example of a unit set. Let us now relate it to the mathematical concept. If we take this example, if X is a set of let's look at this. X is a set of all X such that 2 is less than X, S is less than 4. There is only one element that will satisfy that, and that is S is 3. It's is a unit set. The only element between 2 and 4, which is an odd number, is 3. So it's a unit set. It's a unit set. A set that does not contain any element is an empty set. Another name for empty set is a null set. And we have symbols that we use to represent empty set. We have 2 symbols that we use to represent empty set. You can use either of the 2 symbols to represent empty set. Either this or this. Now this is the curly bracket that contains the element. You know that the curly bracket, there is no element inside. It signifies is an empty set. It signifies it's an empty set. It's an empty set. Let's quickly take this example. T is equal to the set of human beings with 4 heads. Have you ever seen a human being with 4 heads before? You don't call it human being again. It has become a monster. So it's an empty set. It's an empty set. So we write that the number, we write it as T is equals to empty. T is equals to empty. Or we write that T is equals to empty. Either is true. Either is true. Another terminology is cardinality of a set. This is the number of elements contained in a set. That means you count the elements of that set and write down the number of the elements of it. So the number of elements in set S is denoted by n of x. Let's now take this example. How many elements do we have in this set? 1, 2, 3, 4. It means n of x is equals to 4. Let's take another one, P. How many elements do we have in set P? Oh yeah, count. 1, 2, 3, 4, 5, 6, 7. But that is wrong. In set, we don't count repetition. So this is 1. These 2, you take them as one element. 2, 3, 4, 5. Let's take it again. These 2, you count them as 1. 1, 2, 3, 4. These 7 and 7, you take them as one element. 5. Let's take it again. 1, 2, 3, 4, 5. So the number of elements in P is equals to 5. Ignore repetition. Ignore repetition. Ignore repetition. 2 sets are said to be equal if they contain the same element. 2 sets are said to be equal if they contain the same element. Now let us look at the example. Let's look at set A. It contains 1, 2, 4, 6. Let's look at set B. 1, 2, 6, 4. The order is not important. What is important here is that there is a one-to-one mapping. The 2 sets have the same element. The 2 sets have the same element. Therefore, A is equals to B. In fact, the number of elements in A, n of A is equals to 1, 2, 3, 4. And n of B is also equals to 1, 2, 3, 4. 2 sets are said to be equivalent if they have the same number of elements. 2 sets are said to be equivalent if they have the same number of element. P might not be related to Q. In fact, the two sets might not be related. But if they have the same number of elements, they are equivalent sets. Let's take this example. P is the set of cow, goat, sheep. How many elements do we have there? 1, 2, 3. It means the cardinality of P, that is n of P, is 3. Let's go to set Q. We have the element A, B, C. How many elements do we have there? That is 1, 2, 3. It means n of Q is equals to 3. Therefore, we conclude that P is equivalent to Q. Good questions. We want to know the difference between equal set and equivalent set. And if you look at the equal set, it is content based. It is content based. It means when we have two sets P and Q, for them to be equal, the content must be identical. The content must be identical. That is the reason why we are saying it is content based. It is content based. The content must be identical. If the content we have in P is as the same thing as the content we have in Q, then we say P is equals to Q. Conversely, for equivalent set, it is the number of elements in that set. Like the example we have here, we have cow, goat, sheep, A, B, C. They are not related. But if you look at the number of elements we have in P, we have 3. The number of the elements we have in Q, we have 3. So we are looking at the numerical value of P, the numerical value of Q. So how many elements do we have in P? 3. How many elements do we have in Q? 3. So n of P is 3, n of Q is 3. So we see that P is equivalent to Q. The third question is, what is the relevance of set to a real life situation? Or are we just learning set for the fun of it? No. If we have been following the content of this lesson, you can see that this set theory is about being able to observe things. You can observe things in your environment and write down your observation. For example, if you are in a compound and the cars are coming in through the gate, the yellow cars, the blue color, the jeep, if you are very observant, it is possible that out of this car, there are criminals in one of the cars. So if it is a subject of investigation, you'll be able to say, okay, this is what I've seen. So it's about sorting, observation, and classification. At the same time, in the business world, you can use set to find a missing value. A missing value. By the time we get to Venn diagram, you will understand more. When we have two set combination, when we have three set combination, you want to know, okay, which combination, which product mix is better accepted in the society by the customer. We can use set to know that. The missing value. Maybe you have incomplete information, the number of cars, 12, the number of truck, maybe 12. You want to know those cars that belong to both. Maybe they have common value. Then you will use set. You will use set. And that is telling you that we are not just teaching set in abstract. The importance cannot be overemphasized. Even in our kitchen, at home, in our kitchen, you have your set of cutlery in one area. you have your plates set in one area. In fact, your kitchen is made up of set of properly arranged set of so that when somebody enters into your kitchen, you just see that this is a very neat person. Not that we do things in an haphazard manner. And I think with this, you know that it's a topic which you must learn and internalize, because it will really help you to cultivate or inculcate certain habits in the nearest future.